In this lesson, I'll show you how to find the derivative of natural logarithmic functions. We'll start with an easy question and then we will make our way to a harder one. The question reads, derive the following functions. In A, we have y is equal to ln 2x to the power of 3 plus 5x. This one is easy because all we do is follow this template. We will assign this as u. So we'll say u is equal to 2x to the power of 3 plus 5x. Take the derivative of u with respect to x. So doing this implicitly, we end up with du over dx is equal to 6x squared. I brought this 3 down. 2 times 3 is 6. X to the power of 3 minus 1, which is x to the power of 2, plus 5. The power rule was used for both of these terms. We just found this part that we need. Now, we'll write down y prime, which represents the derivative of y, is equal to 1 over my u, 2x to the power of 3 plus 5x, that's my original u, times the derivative, 6x squared plus 5. Combining these two together, these two factors, we end up with 6x squared plus 5 over 2x to the power of 3 plus 5x. That's the answer to A. Let's move on to the harder one. In question B, they want us to find the derivative of ln x times the square root of 2x minus 3 over the third root of 4x plus 1. We need to use the rules of logarithms for this. Notice that we have a quotient here. Whenever you have a quotient, you can follow this rule. So let's split this up before we take the derivative. Y is equal to ln x times the square root of 2x minus 3 minus ln 4x plus 1 to the power of a third. What I did is I switched this radical to an exponent. And you can do that. Mathematically means the same thing. The next rule that I will use, notice that here we have two factors being multiplied. And if you ever have that, you can follow this rule. So let's split this up even further. We have ln x plus ln 2x minus 3 to the power of half. And I will next use this rule for this and for this term. Let's start with this term. We have minus, and whenever you have an exponent, let's say this r, that goes to the front. So our exponent is a third. This will be multiplied to ln, where we have 1 over 3 times ln 4x plus 1. And over here, this half will go at the front. And the function that we will be deriving is written right here. Ln x plus 1 over 2 ln 2x minus 3 minus a third ln 4x plus 1. Now we can actually start to derive using the following pattern. Let's go ahead and do that. Starting with this, we have 1 over, remember this is our u technically, 1 over x times the derivative of x, which is 1. That's good enough. Here, we'll take the derivative of that, which is simply 2. We have 1 over 2 bracket 2x minus 3 times 2. This 2 and this 2 cancel out. Minus a third. We'll take the derivative of that, which is simply 4. This represents our u. So we have 4x plus 1 times 4. My final cleanup will be 1 over x plus 1 over 2x minus 3 minus 4 over 3 4x plus 1. And there you have it. Two examples on how to find the derivative of natural logarithmic functions.